3.1. So I know we briefly covered a little bit of this in class, but just so you guys have it again, let's start with the ready. So this is getting us ready for 3.2. And to make this easier, you guys should pick values for A and B, where A is greater than B. So you don't want to pick, for example, is 2 greater than 4? No, you would not want to use 2 and 4. But you can use this the other way around. 4 is greater than 2. So 4 could be your A and B could be your 2. And then all you have to do is plug in for A. So I'll start number 1 for you. So I would do 3 times 4 blank to 3 times 2. And is 3 times 4 greater than 3 times 2? So you're using these symbols. This means greater than, and this one means less than. So the mouth is going to open towards the number that is bigger. In 4, 5, and 6, you're using if x is greater than 10. So would I want to use 9? No, 9 is not greater than 10. You need to pick a number greater than 10. Can I use 10? Nope, 10 is not greater than 10. It equals it. So I need to use an 11 or a 12 or 13 or a 14 as long as it's bigger than 10. Then you guys can go through and just use your knowledge. You don't need to actually plug in to a calculator for this. I should be able to, for example, number 5. The square root of 11 is blank to 11 squared. You should know the answer to that without using a calculator. But if you're not sure, go ahead and use a calculator. But when we get into 3.2, I will expect you to know which one is greater without using a calculator. All right, so that takes care of the ready. Now the set is very, very similar to what we've done in class. So determine the type of function and then explain how you know. So in class, as we've been working on the task, we've been looking at the differences. So your options here, if I have, well, I don't want that button, that button. Okay, for it to be linear, I'm going to add the same amount or subtract. Okay, add, subtract the same. For it to be exponential, that is when you multiply by the same value. For it to be quadratic, that's when it has a second difference. For it to be cubic, that was another one that we started looking at. It's going to have a third difference. So these are all things that when we start making our foldable for this module that we will add to the foldable to help you guys have something you can keep referencing back to. Now that's for a table. Those are what's going to help you with the table. Sometimes it's neither. But to answer 11 through 15, and I know that these are missing. This should be 7, 8, 9, and 10. It's okay. It's not going to kill you that those numbers aren't there. For 11 through 15, you should be able to just look at the function and pay attention to the exponent. For 11 through 15, pay attention to exponent. So linear exponent is 1, quadratic exponent is 2, cubic exponent is 3, and so on and so forth. 13, here's your keyword in 13. That's going to tell you what type of function it is. 15, well, look where your variable is. Your variable is a blank. I'm not giving you that one. So once you figure out what the answer to that is, then you'll be able to identify what type of function. Your answer's somewhere over here. Okay. That wraps up the set. So now let's go ahead and look at the go. Really briefly, I'm going to cover this. I'm not going to spend a whole lot of time on this. So for 16, f of x. f of x is x minus 3. So I'm going to put x minus 3. Then it's plus g of x. Here's g of x. X plus 2. Now, once I get to this point, I'm going to combine like terms. Like terms have the same variable with the same exponent. So I have an x and an x. That means I have two of them. Then I have negative 3 and positive 2. That's a negative 1. There's my answer. I'm done. Okay, you're just combining functions. You need to simplify them. Please do not throw an equal sign in here and then start solving, because that would not be good. There's no equal signs. Don't throw them in. Okay, that takes care of 16. Now let's look at 17. So 17 is f of x again. So I have an x minus 3. But look at the difference here. The difference with 16 and 17 is one's a plus, one's a minus. So you do have to treat this differently. So it's minus. I'm subtracting the entire h of x. So all of h of x has to go into parentheses. Now I am going to distribute my negative. And if you forget to put the parentheses, you're going to end up forgetting to distribute the negative. And that would be bad. So now I distribute my negative and I am left with x minus 3. Negative times a negative is a positive x, and then a negative times a positive is a negative 1. X and x is 2x. Negative 3 and negative 1 is negative 4. I wrote a little too big. All right. So that takes care of 16 and 17. The rest are very similar, you guys. Again, you can only combine. Let me make a note up here. Like terms. Now, what is a like term? So let's define a like term. Like term, here's the definition for those of you who don't remember what a like term is. Like terms are the same variable with the same exponent. So some examples of like terms. So yes, like terms. X and x. 5x squared, negative 3x squared. 2x to the fourth, 5x to the fourth. Those are like terms. Non-like terms. 3 and an x. X and a y. 3x squared, 3x cubed. It's the variable and the exponent. So pay attention when you guys are going through this. The 3 and the x I cannot put together because the 3 does not have an x. The x and the y, two completely different variables. You cannot put them together. And then the 3x squared and the 3x cubed, they have different exponents. That's what makes them not like terms. So you might want to write that on a post-it note, all of this on a post-it note, and then put it in your book so that way you have it for future reference. All right, that wraps up 3.1. That was short and sweet. Make sure you guys get your homework done and you're ready with some questions tomorrow if you have them.